Alright, welcome everybody to another lecture. In this lecture we're going to study the linked list data structure. The linked list data structure is a very useful and very popular and widespread data structure because it's very flexible. For instance, you can use a linked list to implement a stack, a queue, and basically all of the more complicated and complex data structures have something to do with linked list. Okay, so it's the general case of the linked data structures. And when I say linked data structures, I mean data structures that involve structures and pointers connecting those structures, such as graph and stacks, queues, lists, trees, and so on. So basically, a linked list is a set of nodes, let's draw them. So a set of nodes stored in very different places in memory, and they are connected together. So every node has a value, that's some number, and a pointer called next, which points to the node adjacent to it, to another node, which in turn has value and a pointer that points to another node. And the same thing, it has value and another pointer that points to another node, which has value and another pointer that points to another node, and so on. And the last node here points to null. So our list starts here. So that's the head. It's called the head of the list. And the last node is here, this node, which points to null. So if we want to retrieve any number from the list, we have to traverse the lists. Let's say, for example, I'm interested in the third number. Then I have to loop, iterate through the list until I get to the third number. When I get there, I just return its value or remove it or add another element there or whatever I want to do. So a lot of activities, a lot of operations we can do on linked lists. Okay, and that depends on the application. So we're gonna see a handful of activities that we can do on the linked list, how to add elements, how to remove elements, and a bunch of other stuff. But the rest of the activities are going to be given to you as problems, and you have to solve these problems. And I'm going to, and you're going to find the correction of those problems inside the problem set section of data structures. So to implement this idea, the same thing, just like stacks and queues, we create a struct. So a struct that is called list node. So that's list node. And every list node has a value, and it has a pointer called next, a pointer of type list node that points to the next node. Okay? And basically that's it. Now, if we want to create a list, we have to create another structure which will contain the metadata of this list. It'll contain the head of the list, which node of these is the head, and the size of the list, and basically everything we want to store as an information about the list. Okay? So we have another struct called list. And we said that every list structure has a head pointer that points to that very first element. And it has some other metadata such as size, for example, the size of the list. So we have here a list node, pointer called head, and the size of the list. All right, so let's write that. Let's implement that inside the IDE. So basically, I'm going to create a structure called list node. And every list node has a value and a pointer that points to the next node. Cool, and of course I'm going to add this type def here, struct list node, so that I don't have to say the word struct every time I want to declare list node. And we're going to create the list data structure, which is just a structure that has a pointer that points to a list node, the head node. So that's list node pointer called head, and some metadata such as the size of the list. Cool. And let's add the type def struct list. Now, if we want to create a new list, all we have to do is basically we have to create a struct of a list. So we have to create a list struct, and we have to initialize its head to be null and its size to be 0. Sorry. So let's do that. So basically, it's going to return a list pointer. It's a list pointer function called createList, which takes no parameter, and it creates a node, it fills its value, and then it returns the result. So let's do that. So list L equals list pointer, and we're going to allocate memory for that list. So that's size of list. Now that we have the list has allocated memory, we can start initializing it. So its head takes null, which means that the list is empty. It doesn't point to any node, any list node. And then its size equals 0. And finally, we have to return that list. Another useful function is a function which will tell us whether the list is empty or not. And since that function should return Boolean, we have to include here the standard Boolean library. So it's a function that returns Boolean. It'll tell us whether the list is empty or not. So that's empty list. That takes list pointer L, and it basically returns whether L size equals 0 or not. So if it equals 0, then it'll return true, otherwise it'll return false.